Okay, yes, ठीक है. Okay, can you see my screen? Yes, can you see my screen? Okay, yeah. So we'll start the session. Okay, just a moment. Yeah. So in the last class we started with unit number 2, that is related with the statistics. Okay. Just I'll make my camera on. Yeah. Yes, so in the last class we started with unit number 2, that is statistics. I already told that this unit is not little bit, everything which is available in this unit as a maths. Okay, so we have to deal with some of the problems. So we'll revise the part which we covered in the last class, because I told you that the same concept we required today itself. Okay, so the first we covered the definition of statistics. So by default what we are saying, statistic basically it is a branch of mathematics, and for what purpose we required it. So here we have to understand the data, that is the main agenda behind that. Okay, so we require the statistics for understanding the data. Is my net is okay? Can you hear me? Actually I got some problem. Yes, can you hear me? Please yes, okay, ठीक है, ठीक है, ठीक है. Okay, sorry. Yeah. Okay, so we are talking about the statistics, which is refers to the mathematics and techniques which we require for understanding the data. So in the last lecture we started with this part. Okay, today we will try to complete this part, which is related with the first part related with completely your descriptive statistics. So we are talking in the last lecture we talk entire thing related with a single set of a data. Means here we are talking about a single feature, or that is nothing but a univariate. You can consider as a univariate analysis. Next, from this lecture, or in this lecture we have to talk about the bivariate analysis. So in that bivariate analysis the important concept is a correlation. Then also we have to see the Simpson's paradox. Then also we have to go for the some other correlation caveats which are available with us, and lastly we have to go with the correlation and a causation. So this thing we have to cover. These are small parts. In that the correlation is an important concept which we have to see today. Okay, and then in the next in 2 hours we will complete our probability part. So what we covered, that we'll see initially. So this is a descriptive statistics. Already this concept we covered in our unit number 1, where we are dealing with the exploratory data analysis. In this unit basically they are talking about this two part. One is your first moment business decision, and second is your second moment business decision. Okay, so what is the first moment business decision? In the last lecture we covered that part, that is a mean, median and the mode. So which part we are calling it as a mean? Mean is simply it is what we have a arithmetic mean or average, right? Average means addition of all the elements divided by total number of elements. That we have it as a mean. Median is what? When the data set is provided to you, you have to arrange that data in the ascending order and select the middle value. If you have odd number of case, then in that case easily you will get a middle value. But if you have a even number of case, then the middle value is the average of the two elements present in your list. So that part we covered. So in the last lecture we have gone through the example. In this case, in your INSEM exam, they will go for asking a multiple questions, like they will provide you the list and they will ask you to calculate mean, median and mode for the given list. So everything we covered in the last lecture, and then we started with the second moment business decision. So yeah, so this part we covered mean, median, mode, that is the definition. So what is there in a second moment business decision? In second moment business decision basically we are talking about the measures of dispersion. The important concern we have, it is nothing but what? Measures of dispersion. So how we are calculating the measures of dispersion? We have again a three parts. One is a range part, second one is your variance, and third one is a standard deviation. What is the meaning of range? In a range we are simply taking the maximum value present in your list minus the minimum value. So in this case if you take a equal to what? Suppose 2, 3, 5, 7, 9, 10. In this way if you go in the, this is the, suppose you have it, what we can say, single variable, then in that case we have to calculate a range. So what is the range? What is the max value you will get? The max value is a 10 and the mean value is a 2. So in this way you will be having a range. So what is the range? range is nothing but max minus min, so you'll get the formula as 10 minus 2, that value is equal to 8. This is the range we have, so it's very simple. Next we calculate the variance. How we are calculating a variance? So to calculate a variance, you have this formula, just keep this formula in mind. So the symbol is written at, that is sigma square is equal to summation of xr minus mu square upon n. N is total number of elements available inside this. Suppose in this case if you see, so what is the value of n? For this case, the n value I will write here on the top here. N is equal to what? 6. Total number of elements are 6. What is your mu? Mu is nothing but mean of all the values. So 2 plus 3 plus 5 plus 7 plus 9 plus 10 divided by 6. That will give the mu value, some value of me. And what is your xr? So first number, that is 2 minus mean, and we are taking a square of that. For second number, 3 minus mean, square of that, 5 minus mean, square of that, in this way. And at the end we are going to add it. Okay, so you'll get in this way, what you will get, the 2 minus mu, whatever the value of mu is there, square, plus you'll be having 3 minus mu square. In this way this will go up to last value, and this value is divided by n, that is nothing but 6. So in this way you will get a variance. Okay, and after variance, in case of variance, what happen if some values, or that we are calling it as outlier. What is the meaning of outlier? It is the value which is away from your mean. So right now 2 3 5 7 9 10, what is the mean? 10 plus 9, 19, say 26, 20, 31, 33, 35. So this is 35. I will consider as a 36 for understanding purpose. So 36 by 6, this value will come approximate 6. Right, so these are all the values. If you see, my mean is 6, so 6 minus 2, this difference come 4, and 6 plus 10, that is again this difference is 4. So this is we are not having an outlier in this case. But suppose someone has given this value instead of 10, it is 100. Now in that case what happened, this value is 100 is a far away from our mean value, so in that case it is considered as an outlier. Okay, so outliers, they affecting a lot in case of a variance. Why? In variance we are taking a square, and because of a square, what happened, if your mean is 6, 100 minus 6, that is 94, and 94 square, that value is a quite huge value. So because of that we are having a issue. Is it clear? Okay, yes. Right, so that we are considering as what? Variance. And in standard deviation we are taking simply under root of that. So these three things which are representing what? They are representing the measures of dispersion. Clear? Okay, yeah. So this is something about a measure of dispersion. So all these three part related with the first moment business decision, we covered about what? Mean, median, mode. Related with the second moment business decision, we covered about variance, standard deviation, and a range. Okay, and we also consider this example, that is the example of a range. So this is a list you have. The maximum number is 95, minimum number is 64. So your range, you will get it as a 31. I already shared the Jupyter notebook for the last class. I think you might be having that with you. Please go through that for understanding how we are calculating it. Okay, so this is the variance. I simply clubbed it and put it in a slide, so that even if you refer the slide, then we will go through it. In a variance also we are having two part. One is called sample variance, another one is a population variance. Population means we are considering the entire data set, and sample we are considering only a simple part of that. So there is nothing a change. So if you have a population, the capital N, it represents all the value, and if we are having small n minus 1 value, okay, that is small n minus 1, and for that data, this is the x bar, this is the what you can say average or the mean of that. This mu is the complete mean of the entire data set. Okay, so in this way we have the formula. Either you can go for population or you can go for a sample. That's our choice. Then we have also seen how we are calculating a variance. Okay, this is very important concern. Okay, how we are calculating a variance. So initially you are calculating a mean of the data. After calculation of a mean, we are going for the derivative, or we are simply subtracting a mean. So this first value is a 1 minus mean is your 2.857. Second is a 2 minus this, 2 minus this, 3 minus this. Okay, yes, clear. So we will get a value in this way. Is it clear? So this will give the what you can say deviation from the mean. When we will get a deviation at, then what we are doing, what is your this variance? So variation is sigma square is equal to summation of x minus this mu square upon capital N, or all the values of n. So we are getting a derivation, so we are taking a square of that. So this is nothing but what? X minus mu. This is that value. This is x1 minus mu. We have to calculate it for all the stuff, and summation will add this thing. So here we are performing addition between all the elements, and after doing that we have to divide it by n. Okay, is it clear? Yes. Okay, this part is clear. Okay, yeah, so this is sum of square, and at the end what you have to do, you have to perform n minus 1. This n minus 1 we are doing for what? Basically it is a sample variance we have. If it is n minus 1, it is a sample, and if it is a n, then at that time it will consider as what? Your population variance. Okay, so this part we covered in the last class. Then we also covered about a standard deviation. In standard deviation, it is simply we are taking a under root of the variance. That is a simple case we have. Then we started with the interquartile range. We covered all the steps related with the interquartile range. So interquartile range, what we will see, this is suppose your first value, which is 0. So from this 0 to first 25% part is considered as a Q1. From this 0, the 50% part is considered as a Q2, where we have the median also. From this 0, the 75% part is considered as a Q3, and from this 0, the last part we will have, which is nothing but the 100%. So the interquartile range is having a formula, it is Q3 minus Q1. The shaded region is representing your interquartile range. So we also covered the example with respect to that. So there are these values are provided. The first job, arrange the value in the ascending order. So we are arranging this value. So as we have 12 value, this Q1 it represents the 25% distribution. Q2 represents the 50% distribution. Q3 represents the 75% distribution, and lastly, as it is not mentioned here, but this is the Q4 where we have the 100% distribution of the entire data. And what is our interquartile range? Interquartile range is a Q3 minus Q1. Now what happened for Q3? If you see, the total number of values are even. The total number of values are how much? 12. So if you have this is the E1 value, then at that time we are taking the average of this to represent your Q3. So 9 plus 9 divided by 2, that is 9. And for this 5 plus 6 divided by 2, that is 5 and half. And 9 minus 5 and half, this value it will give something like this value. Okay, clear? Okay, okay. And one more example we have seen here. So again we have the same value. We are having 12 values. So out of that, this is your Q1, this is your Q3, and here we will be having Q2. But our interquartile range is Q3 minus Q1, which is 79 minus 50, which is equal to 20. Is it clear, this part? And in the last lecture, we also seen that we have outliers. Outliers are which value? The values which are very much away from the mean. In case of interquartile range, the value which is considered as here, Q1 minus 1.5 into IQR. And what is the value of IQR? IQR is your Q3 minus Q1. So the value which is below IQR, they are considered as a negative outliers, and value which are beyond Q3 plus 1.5 IQR, they are considered as a positive outliers. So here you can see this green dot, these are positive outliers, and this is a green small green dot, they are the negative outliers. Okay, na? So this stuff we covered in the last class. Now in continuation with this, we will go for a next part. Now here when we are calculating all this part, we consider only a single feature. Now we have to move toward the next part where we are talking about instead of considering a single variable, we are considering two features, and that is considered with the covariance. Up to this part we covered variance. Whenever we are adding the word co means between two features we are going to calculate a variance. Okay, so see, variance measures how a single value deviates from its mean, but covariance measures how these two variables vary in tandem from their means. Okay, so how they are going to vary with respect to each other's mean. So here we required two features in covariance, and in case of variance we required a single feature. Now the covariance, it helps to understand the relation between what? Two variables. So it is having three values. One is a positive covariance, second one is a negative covariance, and third one is a zero covariance. What it signifies basically? The positive covariance, it indicates that when one variable increases, the other variable is also increases. It is in mathematical term, it is called as what? What we are calling it as, it is directly proportional. What we can say, it is directly proportional. Right? When one variable we are increasing one variable, the other is also get increases. So that is a directly proportional we have. Now the negative variance is exactly reverse to that. Indicate that if one variable increases, other variable decreases. This we are calling it as what? Indirectly proportional, right? Or what you can say, reverse proportion. Okay. Currently I am unable to recall this. The directly proportional means it is increasing the value, and this will decrease the value. If one increases, other one is your, or we are, I think, universally proportional. Okay, the word is universally proportional. Okay, so in this way we are having this term, and zero covariance suggests that there is no linear relationship, means we can't predict if one is increases it might be possible other will decrease or other will increase, and if one variable will decrease it might be possible other will increase or decrease. So it's very difficult to identify the relation between them. Is it clear? So now we are starting with the relation between two variables. Up to this part we covered the relation between a single variable. Now we are talking about the relation between two variables. Is it clear? Positive covariance, negative covariance, and zero covariance. Only we are having this three value. Is it clear? Okay. So now we'll see how we are calculating a covariance. Again, the same way we have to follow the same formula. The formula for covariance, I will show the formula for covariance. What is the formula for covariance? So see, it is sorry. Initially we calculate the covariance and then we'll go for correlation. Okay, na? So how to calculate the covariance? The first job is we have a x value which is 10, 20, 30, 40, 50, and we have a y value which is again what, 12, 22, 28, 40, 52. First step, we have to calculate the mean of all this. How to calculate a mean? We already seen this in the last lecture. Mean is addition of all elements divided by total number of elements. So we'll get a mean as 30 here. For first feature, the first feature is x. For that mean is a 30. Now the second feature we have, that is a y bar. So for y bar, this mean is what? Again add all the elements divided by total number of elements 5. So that value will get it as a 30.8. So first step is completed where we calculated a mean. Now we have to calculate again a deviation from the mean. So for x we calculated is 10 minus 30, 20 minus this is the deviation from mean. So this will get a deviation from mean for x. Same way we have to calculate a deviation for mean for a y. So we'll get some values. So these are the values which is available for deviation from a mean. Now third is nothing but we have to multiply the deviations. So whatever the deviations we have, that is xi minus x bar, this is the first case, and the yi minus y bar, this is the second case. So we have to multiply both, and it is a element by element multiplication. Means what? Minus 20 is multiplied with 18.8. Minus 10 is multiplied with 8 minus 8.8. 0 is multiplied with minus 2.8. 10 is multiplied with 8.9, something like that. Okay, so we'll get all again the 5 values. This, and these values. Right, this is a step number 3. Step number 4, we have to perform a sum of their products. So whatever the sum we'll get for 5 numbers, we are performing a sum of that. So this value is nothing but 980. And the covariance, it implies, again we have two types of covariance. One is our population covariance, another one is a sample covariance. So in sample covariance, the value which we are taking, it is n minus 1. So what is the sum we have? That is 980 divided by 4. That will give 245 for sample. And for population covariance, it is 980 by 5. That is 196. So I will get the answer as 196. This is basically plus 196. So what plus value indicates? What plus value indicates? Plus value indicates that our two variables, they are highly correlated with each other. What is the meaning of that? If value of one feature is increased, the value of other feature is also get increased. Just understand this part. Positive covariance, what it indicates? If one is increases, the other one is also increases. Negative covariance is what? If one is increases, other is going to decrease. Okay, and zero covariance means you can't predict whether it will increase or whether it will decrease. Okay, clear? Okay. So this is something about what? Covariance. But we have an issue with the covariance. What is the issue? As this value is a plus 196, in some cases you might get some values that is plus 40, or even if you will get a value plus 1. Now all these three values are positive, but it becomes very difficult to understand what is the relation of each other. As all the values are positive, it means that if one is increases, other will also increase. But in which proportion they are going to increases, these values are not provided by covariance. Clear kya? So even if all the values are positive, plus 196 is positive, plus 40 also positive, plus 1 is also positive. But in all this case, you will only understand what? If one variable increases, other variable increase. But in which amount they are increasing, this is not represented by covariance. So to understand that, we have another concept which we are calling it as a correlation. The new concept, we have it as a correlation. Again in the same way, co means between two features. We are trying to find the relation between two features. So to identify that, we have these three values only, plus 1, minus 1 and 0, which was there for covariance also. But in covariance, we have a positive, we have a negative, and we have a 0. But that value, it may have some any range, plus 196, plus 200, plus 400, like that. But here you will not having any value beyond plus 1. If it is a positive linear relationship, relationship, you will not having any value in below -1 if it is negative relationship, and if there is no relationship, you will be having a value 0, right? So what it implies basically, if you have a value closer towards 1, so they have a very strong relationship, right? Just try to understand this value. You will be having -1 over here, you will be having 0 over here, and you will be having +1 over here. The value, suppose I am representing my one of the values 0.8, and I am having one value which is suppose 0.2. So which one is having a highest, what you can say, bonding? So the 0.8 is having a greater bond than that of 0.2. The value which is closer towards +1, it indicates if one variable increases, other will increase around the same amount. If it is more closer towards 1, if it is more closer towards 0, it means they have a relation, but that amount is not that much good, right? Means if one value is increases by 2, the other will increases by 0.2, 0.4, 0.6 in this way, right? In this way. And again the negative, again in the same way, if the value is more closer towards -1, it indicates that if one is increasing in the one order, the other will increases as a -1. But if the value is that is -0.2, then at that time the proportion is less. So the magnitude, we are having an important concern when we are dealing with the correlation. This concern, it was not there when we are talking about the covariance. In covariance case, the magnitude, it was not playing a role. If the value is positive, one increases, other increases. If the value is negative, one decreases, other decreases. Only you can say. But in correlation, what we can say, if the value is more closer towards 1, it indicates that there is a strong relation between two variables. If the value is more closer towards -1, it indicates that one increases, other will decrease. So again there is a strong relation. But if you have in between value, it means their magnitude is having a certain difference. Clear? And if the value is 0, means there is no relationship. And the formula for correlation is what? It is the covariance of two variable divided by standard deviation of both the variable. Is it clear? So we are adding two important terminology here, that is rho x and rho y, which is the standard deviation. In the last lecture already we have seen how to calculate a standard deviation. How we are calculating a standard deviation? Standard deviation is a square root of your variance. And what is the formula of variance? Variance is equal to summation of xi minus mu divided by mu square divided by n. That is the formula we have. So again we have to go for a calculation of the sum, and this is considered as what? Pearson's correlation coefficient, right? In Python you can see some of the codes where they are calculating this formula. So what is the value of r? R always lies in the range -1, and then here I will write r, and this value is in the range of these, where r will never cross this value. So if it is more closer towards 1, it indicates both the variables are strongly positively correlated. If it is more closer towards -1, it indicates both the variables are negatively strongly correlated. If you have the value in between, then their magnitude is also varies in between. Is it clear? Okay. Again we will see the example based on this. This is a completely mathematical part. So what is the first? We have x, we have a y. What is the first step? Calculate a mean. In the last example also we calculated mean. Mean is what? Add all the terms divided by total number of terms. 10 plus 20 plus 30 plus 40 plus 5 divided by 5, that is 30. Basically this value is what? 150 upon 5, that is 30. And then for y it is 12 plus 22 plus 28 plus 40 plus 45 divided by 5. This will give the value as 30.8. Okay, the first marks we will get here. Second is calculate the deviations from the mean. So what is the deviation? First value is a 10, your mean is a 30. So what is the deviation? It is 10 minus 30. Second is 20 minus 30, third is 30 minus 30, 40 minus 30, 50 minus 30. You will get one, what you can say, list here. Same way we have to calculate it for y. The mean of y is 12, 30.8. The first value inside of y is at 12. So you will get a value 12 minus 30.8, 22 minus 30.8, 28 minus 30.8, 40 minus 30.8. In this way you will get again a 5 value. Now we have to move to our third step. What is third step? Multiply it, as we have to go for a covariance. Covariance is simply a multiplication of all the numbers. So minus 20 multiplied by minus 18.8. It is a element by element multiplication. Again keep a focus on that. The first value is multiply with the first value. Second is multiply with the second value. Third is multiply with the third value. Fourth is multiply with the fourth. So again you will be having 5 values, and we are getting that 5 values here: 376, 88, 0, 92, 424. And what is next? We have to sum all the products. So that value will give you the value as a 980. And when we are dividing, the population covariance is what? Divided by total number of elements. Total number of element, that is n, is equal to 5. So 196 is my covariance. Up to this part we covered in the last problem itself. Now what is second part? Now our expression indicates what is that? We required what? Standard deviation of x. We required standard deviation of y. What is the formula for standard deviation of x? Standard deviation of x is nothing but, it is again what we have, under root of. Now already we calculated a difference here for x. So the difference is this. So we have to take the square of each and every terminology and we have to add it. Minus 20 square plus minus 10 square plus 0 square plus 10 square plus 20 square. So here they are adding it: minus 20 square plus minus 10 square plus 0 square plus 10 square plus 20 square upon 5. Okay, and we have to take the under root of that. Why under root? We are talking about the standard deviation. If you will not take an under root, that will consider as a variance. So the 200 is a variance, but under root 200 is your standard deviation. So the value for x it will get as a 14.14. Same way value for y, the standard deviation of y, will get the value as 13.95. And lastly, the Pearson correlation coefficient R will get the value of 196, which is your covariance. 14.14 is your the standard deviation of x. 13.95 is the standard deviation of y. Simply multiply this value, so you'll get a value 0.993. So what you can conclude from this? What is the range of this R? R का range क्या होता है? R is in the range of -1 to 1. This value is more closer towards 1. So that's why what they mentioned here. See here, the Pearson correlation coefficient R is approximately 0.993, indicating a very strong positive linear relationship between x and y. This is the conclusion we have. Is it clear? The covariance and correlation. This part is clear. Okay, yes. Hope so this part is clear. Now we are moving toward the next part. Covariance as well as correlation, mostly covariance part, they are not actual representation. And that's why we are having a paradox. What is the meaning of paradox? Yes, paradox means what? We can say contradiction. Okay, so what we are saying, just read it properly, and it is again a what statistical phenomenon we have. So Simpson paradox is again a statistical phenomenon in which we are trying the relationship that appears in a different groups of a data reverses or disappears when these groups are combined. What is the meaning of that? Yes, what is the meaning of that? Just they have given one example. Just see this example. Now we have to understand what is the Simpson's paradox here. So we are considering one hypothetical situation where two groups of patients are being treated with the two different drugs, drug A and drug B. These are the two drugs we have, and we are having two different groups. So we are treating on them. The success rate of each drug is evaluated separately in men and women. So what happened for men? Drug A is 90%. Its success condition is 90%. And for drug B in a man, the success rate is 80%. Okay. The same drug, if you consider in a woman, it is what? 10% for men. 10% for drug A in woman and 20% for a drug in drug B for a woman. Clear? So now just by observing this, what you feel? The drug A is having more, what you can say? It is more good for the men, as well as drug B also is more good for what you can say men. Clear? But now what happened here? Just this is the important part. When we are combining both the drugs, okay, see here the important part. In both the cases, drug A appears to perform better for men and drug B also performs better for women. Okay, how? Okay, okay, yes. So drug A appears to perform better for men while drug B performs better for women. Okay, na? But now what happened when we are combining both? What happened? Drug A, 100 out of 200 patients were successfully treated. So the success rate becomes now 50% here. And for drug B, 100 out of 200 patients, again that becomes 50%. Initially, what was your percentage? For men it was 90% and 80%. And for women it was 10% and 20%. But now we combine both the drugs, drug A and drug B. So what percentage you are getting? For drug A you will get a 50%, for drug B you will get a 50%. So this is the paradox we have. Initially we are saying that we are having very good connections for drug A and drug B for men. But now when we are combining for all the patients, the percentage is reduced up to 50%. So this is considered the Simpson's paradox. Clear hai kya? So when we are combining two, what you can say, sets, then at that time your correlation is get reduced. That's what they want to say. So see here, the explanation they have provided. When the data is combined, the overall success rates are identical. However, this aggregation hides the fact that, which fact it is hiding? Drug A was more efficient on men and less efficient for women, while drug B was more effective for women and less effective for men. Actually, they made a change here. This should be, see, it should be 20. So this will become basically 20% and this should be 80. The explanation is based on that. Okay. So drug A is good for whom? The drug A is good for men, and drug B is good for whom? Drug B is good for women. But when we combine both the drugs, for we are not discriminating with respect to men and women. So what happened in that case? So the 100 samples are there. Out of 100, means 100 out of 200 patients were successfully treated in both the cases. So the success rate becomes 50% here. And in this case again 100 out of 200 patient, it will become 50%. Now from where 100 comes, for drug A 90 men are there and 10 women are there. So this 100 plus 100 200 and this 90 plus 10 100. Clear? Same way for drug B also, this is a 20 out of 100 and 80 out of 100. 100 plus 100, total patient become 200. For men it is 20 and for female it is 80. So 80 plus 20 100. In this way, when we combine both the stuff, we will get the 50-50%. So basically what happens, this is the important part. Just go through it in a very proper way. That is the Simpson's paradox. What it says, when the data is combined, the overall success rates are identical, 50-50% in both the cases. However, this aggregation hides. What it hides? The fact that drug A is more efficient for men and less effective for a woman. Drug A is less effective for women, and while drug B is more effective for women and less effective for men. This is the important characteristics which is hidden inside a Simpson's paradox. Okay, in some cases combining the data can even lead to the positive opposite conclusion, such as indicating drug B is more effective overall even though drug A is more effective within a each search group. Okay, it might be possible. We'll get some other example there. Okay, like this. Is it clear? So this is considered the Simpson's paradox. Is it clear? This concept is clear? And in your exam, on this there is a theory question. On Simpson's paradox, they will ask you the theory question. Explain the concept of Simpson's paradox. What Simpson's paradox says? Simpson paradox basically it talks about what? When two groups are appearing different. So here the example you can give, we have a drug A and drug B. The drug A and drug B we tested on men as well as we tested on women. So what happened for drug A? The 90%, okay, 90 out of 100 men are successfully treated by drug A, and 20 out of 100 men were successfully treated by drug B. And the same we have applied it for women. So women we have a different case. 10 out of 100 women are successfully treated and 80 out of 100 women were successfully treated by drug B. But if you try to combine with respect to patient, so drug A it cures 100 patient out of 200, and at the same time drug B also cures 100 patient out of 200. So their success rate it becomes 50%, which was initially for men क्या था drug A का, for men it was 90%, and for woman what was it? It was a 10%. And for drug B what was it? So for men it was a 20%. And okay, it was like that now only, and for woman it was what? 80%. Right? Clear? Okay? Yes. So this is considered as Simpson's paradox. Now we are, yes, what is the importance of that Simpson's paradox and all the stuff? They have given these two examples. Out of that we will see this medicine example, because right now also we have seen the same example here. Medicine example for a gender. Okay, So see, treatment effectiveness might appear different when broken down by subgroups. In our case, we divided the treatment as a gender, men and women, but you can also divide it as a age. Whatever the drug A is there, it might be good for a person, those who are having a, or the elder person, and the drug B, it might be good for what you can say small children. So we can divide it with respect to age also, and with respect to gender already we have seen in our case. Okay. So if they ask the question, you can write in this way. That is the case. Okay. In the same way, we can consider in the same manner like a sports, like they have given the example of a baseball. Okay. So what example they given? A player might have a higher batting average in two different seasons. Okay. So one player is there who is having a different average in both the sessions. It might be a higher one, but when the seasons are combined, another player might have the high value as overall. Clear? Means suppose A is a person, right? So it might be having a suppose 50 in season 1 and suppose 60 in season 2. Okay, this is season 1 and this is what? Season 2. Okay, so what they said, it might be possible, suppose for season 1 there is a one person which is having around suppose 49. Okay, what they mention? Yes, higher batting average in two different seasons. Okay, but when the seasons are combined, another player might appear to have a higher overall average. Okay, okay, average, they are considering it as average. Okay, so this might be 30. Okay, so if you take the average, you might be having this one as a higher one if they are acting as a separate one, but it might be possible, right? But when the seasons are combined, okay, other player might have the greater average here. So here you might be having one person which is having an average like as a 61, 60, right? So in this way, this person, it might be having what you can say the higher overall average. In this way they consider the example. Okay, instead of sports, the medicine is a good example because already it is explained over here. Okay, this actually this concept, it is just a theoretical concepts we have. So for understanding purpose, you can explain this concept in a proper way, drug A and drug B. Okay, that is the Simpson's paradox we have in our case. Now we are going for some other correlational caveats. So some other cases of a correlation part. So see here, they have represented two values. What are these two values? X is -2, -1, 0, 1, 2. And what is Y? Y is 2, 1, 0, 1, 2. Now can you tell me, is there any relation between X and Y? Are we having a relation between X and Y in this case? The answer is no. Why we don't have any relation here? See, if X is -2, Y is 2. Okay, if X, in that way if you see, -2 and 2, they are the opposite. Okay, one is negative, one is positive. This is -1, 1, it is negative, it is positive. Okay, 0, 0 is also okay, but if it is 1, then with respect to first terminology, this value should be -1. If it is 2, it should be -2, but it is not the case. So what this will do, what your correlation will do, or what your covariance do, it will give the relation between both them as a 0. Is it clear? As there is no relation, it might be possible up to this part you will be having a negative relation, but here you will be having positive relation. So in that way, combiningly you will be having no linear relationship. There is no linear relationships here, but it is not the case. What will you say? Y, if you say Y is nothing but it is mod of X. Yes or no? If you see properly, if X is -2, Y is 2. If X is -1, Y is 1. If X is 0, Y is 0. If X is 1, Y is again 1. X is 2, Y is again 2. So Y is mod of X. So this type of relation, it is not coming inside a linear relationship. But this is also possible. This is also one type of a relationship. That's why it is mentioned some other correlation caveats. Okay, clear? Then next caveat we have. So see, -2, 1, 0, 1, 2. The X value is that. Now in this case, if you see, the -2 is represented by suppose 99.98. If this value, actually it should be -1, -2 to -1, then this value, Y value is incremented by 1. -1 to 0, this becomes 100. Now 0 to 1, it becomes 100.1. and then 1 to 2 if you go, this will become 100.02. Okay, now as such, if you see, if you go with the correlation or the covariance case, then there is no relation between x and y, you can see. But if you see properly, there is a relation between x and y. For x, the change in the amplitude of x by 1, that is represented as 0.001. If x is changed by 1, then what is the change in y? Y is changed by 0.01. But this relation is not represented as any linear relationship. Okay, so this is again one types of a what you can say caveats we have. So we are having these two example, which are the caveats available for your correlation. Is it clear? This mod relation and this second relation is not represented in terms of your correlation parts. We have some this is again a one relationship, but we can represent in this way. So that's why it is mentioned as some other correlation caveats. Is it clear? Yes. Is this part is clear? Okay, okay. And this is again theoretical one. For this again they will be asking 1 or 2 mark question, not more than that. Okay, and the last part is nothing but what? Correlation and causation. What is the meaning of correlation and causation? Very simple. Correlation between x and y. What is the meaning of correlation between x and y? What is the value of correlation? Which value we are using? Small r. What is the value of small r? Small r is always in the range of -1 to +1. -1 indicates this both the value x and y, they are negatively correlated. What is the meaning of negative correlation? If one increases, other will decrease. And positive one, what it indicates? If one increases, other will also increase. And if 0, it indicates that there is no correlation between x and y, right? Clear? But now what is the meaning of causation? If the values are related with each other, then at that time these values are causing each other, means x may cause y or y may cause x, or both may cause each other or both may not cause each other. That is a simple one line explanation available for correlation and causation. So read it properly. You have probably heard at some point that correlation is not a causation, most likely by someone looking at a data who posed a challenge to pairs of his word view, that he was reluctant to the question. Nonetheless, this is the important point. Now this is important here. See what is written. If x and y are strongly correlated, that might mean that x causes y, that y causes x, that each causes each other, and that some third factor causes both, or it might mean nothing. So there are 5 cases we have related with the causation. If x and y are strongly correlated, okay na? If both are, see this from this part to this part, it is very very important. If x to this part till the nothing. So we have 5 cases. Which are the 5 cases? First case, if they are strongly correlated, then x causes y. First case what we have? We may have x which is causing y. Because of x there is a y. Or we have a second case. What? Y causes x. Then we have a third case. What is that case? Each causes each other, means x causes y as well as y causes each. That is the third case we have. Or we have fourth case. What that? Third factor causes both. There is one more factor which might be there, which will cause x and y. Or the last case is that it might be mean that we have a meaning that no one causes each other. There is no relationship between each other. Is it clear? Okay, so that is a definition we have. Correlation and causation. Causation का मतलब है, what is the meaning of causation? If, as we have a 2 variable, in correlation we are always talking about 2 variable. In causation also we are checking that is there any cause, because of that this thing happens. So how many cases are possible? As we have 2 variables, we have 5 cases. Which are that 5 cases? X causing y, first case. Second case, y causing x. Third case is what? Both causing each other, means x causing y and y causing x. Fourth case is that there is another factor, suppose z causing x as well as z causing y. And last case we have there is nothing relationship between all this. there is no causation between all of this stuff. So this is the point which is available for this. Is it clear? Is this point is clear? Okay. So in this way, basically the first part related with this unit 2 is going to end here, in which we are talking about the statistics. In which we are talking about what? Statistics. Okay. Then from tomorrow we'll see about the probability. What is that? In describing a single set of data, again I will repeat that part. We have first moment business decision, second moment business decision. What we have here? We have mean, then we have what? Median, and we have a mode. That is first business decision we have. Second business decision we have a range. Next we have a standard deviation, and we have a variance. So it is expected to have a problems on all these 6 steps. So we already covered all the problems in the last lecture related with mean, median, mode. Okay. So we have the formula. Now in this lecture we covered the problems related with the range, variance and standard deviation. Okay. So we are having this as a range. Range is a max value minus mean value. Standard deviation, we might be having population, or we might be having a sample. Based on that we are calculating it, and we have seen the entire, what can I say, description of that, how we are calculating it. Okay, how we are calculating standard deviation. Next we covered about the interquartile range. So interquartile range is represented at Q3 minus Q1. What is Q3? Q3 is a 75% data from 0. Q2 is your 50% data. Q1 is a 25% data. Okay, and we calculated it. We also consider about outliers. In this lecture we talk about a covariance. For covariance we will get a 3 values, either positive, negative and 0. Covariance is used for 2 variables, your mean, median, mode. Variance, standard deviation and range, this is used for a single variable. And for as we are moving toward the covariance, we are having 3 value: positive covariance, negative covariance and 0 covariance. Positive covariance indicates that both the variables are strongly related to each other. Negative relates that if one increases, other will decrease. That is inversely proportional to each other. Okay, and 0 indicates that they don't have any relation between each other. Again we have seen how to calculate it. First is we have to calculate a mean. Second, we have to calculate a deviation from mean. Third, we have to multiply the deviations of both the variables. Then we have to take the sum of that, and lastly we have to calculate the sum of variance by dividing total number of elements in our list. That we covered. But what is the problem with covariance? Covariance, for all the positive value we have to consider the same thing. If one increases, other will increase. There is no as such relation between your what you can say, magnitude related with your different elements. So to deal with this, we are moving toward the correlation. So correlation is again having the same thing. For a positive value which is there in covariance, that is represented as +1. The no relation is represented as 0, and the negative value representing a negative correlation. But here the magnitude plays an important role. If value is more closer towards 1, means both the variables are strongly correlated to each other. If value is more closer towards -1, it implies both the variables are strongly negatively correlated with each other. Means if one increases, other will decrease in the same amount. And if the value is more closer towards 0, then at that time as such they don't have any strong relationship. Okay, and what is the formula for correlation? The formula for correlation, it requires your what? Covariance. We have a covariance. So covariance of xy divided by standard deviation of x and standard deviation of y. So this stuff we covered here. Okay, so initially we are calculating a mean. Next we are calculating a deviations from the mean. Third step we are calculating a covariance, and then we are calculating a standard deviation of x and standard deviation of y. Okay, and that will give you the value of r, which is your correlation coefficient, which is always in the range of -1 to 1. Okay, okay. Then we cover about the Simpson paradox, which talks that when two features they are different, they are acting individually, they have some other efficiency, they have some other value, but when we are combining it, then it will give some other value. Okay, so this example we covered in Simpson's paradox. Then we covered about some other correlation caveats. In that we are considering 2 cases. One is a mod case and second one is a change in the value, it is for x it is huge, but for y it is very small value. This is not represented in our correlation case, but it is again one type of a correlation. So in first example, what is the correlation? Y is equal to mod of x, and in second case, if x changes in a huge amount, y changes in a very small amount. So in this way we are representing it. And last part we covered, that is a correlation and the causation. So as we are talking about in correlation, we are talking about two variables, x and y. So we are having 5 cases, which are that first is x causes y, second is y causes x, third both causes each other, means x causes y and y causes x. Lastly, the third variable z, it causes x as well as it causes y, and lastly it might be possible no one cause each other. So in this way we are having a relation between correlation and causation. Okay, hope so these points are clear. I will share this presentation with you. Go through this. These points are little bit easy, but there are certain mathematical calculations are there in this case. Okay, in the next class we require 2 lectures to complete this probability, so we'll try to complete in the next week, mostly on Wednesday, Thursday we will try to complete this part. Okay, clear? Okay, and I think ma'am has shared the INSEM paper. We'll discuss that INSEM paper on the Wednesday or Thursday. We'll try to cover it. Okay, okay. Is it anyone is having any question? Yes, anyone is having any question? If you have the question, you can ask me.
Sir, I have a book which is called Data Mining, which is from means MK Publications. So, do you think it's means efficient, or it's okay to use this for the subject?
See, in that data mining, you initially go through the syllabus first. I will recommend that. Okay, but if you ask me, whatever the presentations I have given, they are more than enough. Okay, still now I have received the INSEM paper. I will again go through that. But as per the syllabus which is decided by Pune University, whatever is there, it is more than enough. Whatever we covered. But still, I will go through that part and then let you know on Wednesday when our next lecture is there. Okay?
Okay.
Yes. Any other question?
So, if possible, can you discuss some questions or a paper in some paper with us?
Yeah. So that's why I said, just now I think ma'am has shared the papers on a group. We'll go through that paper and we'll discuss that. No issue.
Yes.
We'll discuss the questions. Yeah. Okay. Okay, so we'll stop here. Till that point, you go through the different stuff what we covered. For second unit, most probably there will be the problems. They will go for because there is very less chance to ask a theory question. Most probably they will go for the problems, but still we'll see the INSEM paper and we'll discuss that on the next lecture. Okay. Okay, sure. Thank you so much. So now the next lecture I will let you know. Mostly it will be on Wednesday, Thursday, but if possible to me, on Monday, Tuesday also will try to complete it. Okay, so that you will get a time for study purpose. But we covered around 1.5 unit. We completed 1.5 unit. Only 0.5% part is remaining, that is related with the probability. So you prepare this 1.5 unit. Okay, sure. So thank you so much. Okay, bye bye. Take care. Good day. Bye.